Hi friends, in this video we solve problems related to RL transient. The question is, for the circuit shown in figure, find the current equation when the switch is changed from position 1 to position 2. Right? So this is position 1, this is position 2. Right? We have to find a current equation at t is equal to 0. So switch moves to position 2 at t is equal to 0. Let us solve this problem. Right? So when t is less than 0, that is t is equal to 0 minus, the circuit will be in position 1. Fine? So it will be like this. Right? So this is 100 volt, this is 20 ohm, this is 30 ohm. Right? So here it is steady state current. So we know that inductor is short for steady state current, so it will be shorted. Fine? Okay, so now what is the current flowing through the inductor? They ask current through the circuit. Current through the circuit is nothing but current through the inductor. So now I is equal to, that is I0 minus is equal to 100 by total resistance 50 V by R, so 2 ampere. Fine? Okay. We know that inductor cannot change the current immediately. So I0 minus is equal to I0 plus, which is equal to 2 ampere. I0. Okay. When t is greater than 0, or t is equal to, when t is equal to 0, the switch is moved from position 1 to position 2. Right? I want to find t is greater than 0. Fine. So that is t infinity I want to find. Why I find t infinity? Let me tell you. So what happens? This is given by when t is greater than 0, the switch moved to position 2, the circuit will have only R and L. Okay. So R of 30 ohm and we have L, R. Right? So what is R value? 30 ohm, L is 0.2. Sorry. And so this is 30 ohm, this is 0.2 Henry. So what is the current flowing now? Now the current flowing through the circuit is 0. So I infinity is 0. So initial current is 2 ampere, final current is 0 ampere. So we know current flowing through the circuit in RL circuit is I of t is equal to I infinity plus I of 0 minus I infinity e power minus t by tau, where tau is equal to L by R. So that tau is a time constant that we have to find in the final stage. What is L value here? 0.2, R is 30. So 0.2 by 30. Substitute all the value. I of t, I0 is 0. I infinity is 0. I0 is 2. 0 e power minus L by R is 30 t by 0.2. So I of t is equal to 2 into e power minus 150t. This is the answer. Fine? Okay. Next we solve second problem. Right here for the circuit shown in figure, switch is in position 1 for long time and brought to position 2 at t is equal to 0. Right? What is it? Determine the current through the inductor. So again we have to find the current through the inductor. So switch is in position 1 for long time. So current through the inductor is given by I of t is I infinity plus I of 0 minus I infinity e power minus t by tau. Right, first condition when t is equal to 0 minus, that is switch is closed at t is equal to 0. When I draw t is equal to 0 minus, what will be the condition? The circuit will be like this. Right, so switch goes to position 2, right, as per the problem, and brought to position 2 at t is equal to 0. So before t is equal to 0, switch is in position 1. So circuit will be like this. 5 ohm, 50 volt. Fine. And I told when we apply steady state voltage, inductor will be short. So it will be like this. So it is current through the inductor. Now what is current through the inductor? I0 minus is V by R. 50 by 5, it is 10 ampere. Okay. Now when so inductor cannot change the current immediately. So I0 minus is equal to I0 plus, that is equal to I0 is equal to 10 ampere. When t is greater than 0, the switch comes to position 2, because at t is equal to 0, switch comes to position 2. The circuit will have 10 volt, 5 ohm. So circuit will have 10 volt, fine, 5 ohm, and inductor is again short for steady state voltage. So it is short 10 volt. Now what is my current through the circuit? Let me find I infinity. So t is greater than 0, I find I infinity. That is given by 10 by 5, 2 ampere. Now I have to find tau. Tau is equal to L by R. What is L value here? L is always 2 Henry. So L is 2 Henry. Fine. R is 5 ohm. So we have to find value at L at time constant at tau is equal to infinity. So here L is 2, R is 5. So 2 by 5. Okay. 2 Henry, just I put it. Now I of t is nothing but, what is the formula? I of t, current through the inductor, is given by I0. I0 is, I infinity. I infinity is 2 ampere plus I0 minus I infinity into e power minus t by tau. T by tau means it is 5 by 2t. So I of t is equal to 2 plus 8 minus 8 into e power minus 2.5t. This is the current through the circuit. Okay, and the next problem is obtain the current I1 and I2 value when switch is closed at t is equal to 0. So I1 is this one, I2 is this one. Switch is closed at t is equal to 0 only. Okay, so first what we are going to see. Okay, let us solve this problem in a simplest fashion, right? So switch is closed at t is equal to 0. Okay, so fine. Okay, so switch is closed at t is equal to 0. When t is less than 0, it is opened. So we have only R and L. No current flows through the circuit. This is I2. I1 is nothing. So I1 of t 0, I2 of t 0. Because before less than 0, no supply is there. So current is 0. Okay. When t is greater than 0, what happens? When t is greater than 0, switch is closed, because switch is closed at t is equal to 0. Now the circuit becomes like this. This is 50 ohm, this is I1 of t, this is I2 of t. When we apply steady state, inductor is short, so it will be shorted, right? So 10 ohm is there. Now I have to find I1 and I2. So first I find current, total current, then I find I1 and I2. So V is given, so I is nothing but total current. I is given by 50 by total resistance R total. R total is nothing but these two are parallel. This is 20 ohm. So 20 into 10 divided by 20 plus 10, 200 by 30, that is 20 by 3. Fine. So I is equal to 50 divided by 20 into 3, 150 by 20, that is 7.5 ampere. So I is equal to 7.5 ampere. So current coming through this is 7.5 ampere. So I can say this is I1 of t, I1 of t are greater than infinity, right? So greater than 0. So it is 7.5. This is 10, this is 20. So here 2 times less current will flow, here 2 times more current will flow. So this is 5 ampere, this is 2.5 ampere. So this indicates I2 is 5 ampere. So I1 is 7.5 ampere, I2 is 5 ampere. Oh, fine. Okay. Now what we have to do, initial current is 0. So this is infinity, steady state current. So I1 infinity is 7.5, I2 infinity is 5 ampere. Right? Why it is steady state? Because I apply steady state voltage. So the circuit reaches steady state. So infinity is 5 ampere. Okay. Next we have to find tau value. Tau is equal to L by R. L is, as per the problem, what is L value? 1 Henry. Right? So 1. Okay. Now we have, you see the circuit is having two resistor. Whenever we are having two resistor in the circuit, R is nothing but Thevenin's equivalent resistance. So how can we find the Thevenin's equivalent resistance? This voltage source must be shorted, and this one will be like this, and this one 10 ohm will be like this. Fine. So what will happen? This is nothing but this 20 ohm. So I find R Thevenin. So this short will become short. So this is 0 ohm, this is short. So the resultant will be having only 10 ohm. So R Thevenin is 10 ohm. So now, sorry, I of t is nothing but I0. First I1 of t I find. I0, sorry, I infinity, I1 infinity is 7.5 plus I0. I0 is what? I of 0 we found or not? Yes, I of 0 we found. That is 0 minus I infinity again 7.5 e power minus L by R, that is 10t. So I1 of t is 7.5 1 minus e power minus 10t. Okay. Similarly, what about I2? I2 of t. I2 of t is given by, what do you call, I2 of infinity. I2 of infinity is 5 plus I0 0 minus I2 of infinity minus 5 e power minus 10t. So 5 into 1 minus e power minus 10t. This is what I2 of t. Right? Okay. Next one, in the circuit shown in the figure, find the transient current and the initial rate of growth of current. Okay, fine. So how we are going to find? So let us see. When first I find, so circuit is given like this. So when t is equal to 0 minus, what happens? This is I of 0 minus. The circuit becomes like this. How it will become? It will be, I draw like this. This is like this. So inductor will be short, and we have one resistor, 5 ampere. Fine, 100 volt. Okay. So here we know initially there is a current flowing in the circuit opposite. Initial current they have given, which is flowing in the opposite direction. So it will be minus 6 ampere. Right? Actually, original current flows in this direction, but they have given initial current in this direction. So I0 minus is minus 6 ampere. That is equal to I0 plus, because inductor will not allow sudden change of current. So that is equal to I0. This is for I infinity. I infinity, what is the current flowing through this circuit? This is simply V by R, because when I apply steady state, inductor will be short. So this implies I infinity is, sorry, this is 5 ohm, 20 amps. Okay, now what is my, I have 1 tau. Tau is equal to L by R. L is equal to 3. This is 5. So I of t is I infinity plus I0 minus I infinity e power minus t by tau. I infinity is 20 plus I0 is minus 6 minus 20 e power minus 5 by 3t. Fine. Okay, this will indicate 20 minus 26 e power minus 5 by 3t. This is what current through the circuit. But what they ask is initial rate of growth of current. Initial rate of growth. Initial rate of growth of current is nothing but what is di of t, rate of change at t is equal to 0. This is what initial rate of growth. So when you differentiate, it will become 130 by this 25 by 20 by 5 3. So e power minus 5 3 into t. When you substitute t is equal to 0, it will become 1. So it will be 130 by 3 per ampere per second. This is what, why it is ampere per second. Current is ampere, t is second. So the unit is 130 by 3 ampere per second. And next problem is sorry. Determine the current I of t and voltage across resistor and voltage across inductor of the circuit shown in the figure. Right. So let us see this problem. Okay, this is also very simple. So yes, okay. So the circuit is switch is closed at t is equal to 0. Please write it. Switch is closed at t0. So t is equal to 0. The switch is closed. Okay. So when t is less than 0, that is t is equal to 0 minus I of 0 minus equal to 0. Because what is the reason? The circuit will be simply R and L. There is no source. So inductor will not allow sudden change of current. So I0 minus equal to I0 plus, that is equal to I0. Next, when t is greater than 0, the switch is closed. So circuit will be having like this. When you apply steady state, what happens? Inductor will be short, 30 ohm. Now I find what is steady state current I infinity, V by R, 60 by 30, 2 ampere. Okay. So what about I of t? I of t is I infinity plus I0 minus I infinity e power minus t by tau. Tau is equal to, what do you call, L by R. L is 15 ohm, right? Under steady state, what is R value? We have only one resistor, 30, 1 by 2. So I of t is equal to I infinity 2 plus 0 minus 2 e power minus t. 1 by 2 is 2. Okay. So it will be 2 into 1 minus e power minus 2t. This is what I of t. Okay. So what we found I of t. Next to voltage across resistor. Voltage across resistor is simple, nothing but V R of t is equal to I of t into R. R we have only 30 ohm. So it is 60 into 2 into 30, 60, 1 minus e power minus 2t, because R is equal to 30. Next VL. VL is equal to L di of t divided by dt. L we know it is 15 Henry. So 15 into d by dt, 60 minus 60 e power minus 2t. This one I substitute. Okay. So it will give, what you get is okay. So L is 15 e power minus 2t. So when I differentiate, 1 minute, when I differentiate, it will become okay, I of t is, sorry, I of t is 2 into this one. Please change it. This is VL, not IL. So I of t d I of t by dt. I of t is nothing but 2 into 1 minus. So it will become 2 into 2 minus e power minus 2t. Differentiation of 2 will be 0. It is 4 into e power minus 2t. So 60 e power minus 2t volt. So VL is equal to 60 into e power minus 2t volt. VR is 60 into e power 1 into e power minus 2t. Fine. So that's all about this session. If you have any doubt, please ask me in comment section. I will clarify. Thank you.